So stratified sampling. All right, so yeah, let's check Google for more. So we come to Google, then we say stratified. We say stratified sampling. All right, random sampling, which is there. Okay, so you can look at some images. So this is a typical image. We use that to demonstrate what it means to say stratified sampling. So you check this, alright? So we see the bigger population is this uh, this black line. See this black line, right? Is a whole population, and we divide the population into four. So group 1, group 2, group 3, group 4. Okay, I want to pick a sample, but this time around we are not picking a sample from just this one or that one, but we'll pick a sample from each of them and combine them to get our sample. Okay, the reason why we do that is assuming you want to look at the salary or in a certain company. All right, you have to be realistic. You can't combine all of them. All right, you can't combine all of them because they don't look very homogeneous. They are different. There are a lot of differences. So you might have to look at the security guards and then the cleaners, put them in one group. Okay, you look at those normal workers, also put them in another group. Executives, put them in another group. Sales boys, those who come in to do some take things and bring in and get commissions, you put them also in another group, right? So in that case you become fair, so that you pick a sample from the security people to represent the security guys, pick sample from the executive board to represent them. That look like more representative. Okay, assuming you combine them and then you decide to do simple random sampling, and it happened that your probability sampling technique just picked everybody, only the normal workers, or picked only the executives. Your mean you calculate will not look like the mean salary of the people in that company. It will not look like that. Okay, so that's why simple random sampling at times it doesn't work anywhere. So for samples where for population where there is this heterogeneity, where there are a lot of differences, that means the whole population is not homogeneous. Okay, you can't really do a simple random sampling. So more appropriately, simple random sampling works better when your population is homogeneous. That means everybody in that set of population, they are equal. Okay, like not equal as in they are equal, but you can say that they are relatively on the same level. Okay, so probably you go to a certain estate where everybody certainly owns a car, the house belongs to them and stuff. You look at them, their living standard of living is almost the same. In that case, that population look very homogeneous. Okay, so you can consider them. Right, but when you go into, let's say you now extend your boundaries, considering a place where it is clustered, a lot of people are there, debt and stuff is there, and you want to combine them with those people living in estates and then do a survey for both of them. You wouldn't have to combine them and take a sample. You have to divide them into groups and take sample from that, tap sample from that, so that they will look representative. Okay, so that's a typical stratified random sampling. So you use a simple random sampling to pick a sample from group 2, use simple random sampling to pick sample from group 1, and do same to pick from 3 and 4. Put them together to get your sample. Very nice technique, isn't it? All right. So let's look at the cluster sampling. Okay, so cluster sampling. So So cluster sampling is a method of selecting a sample from a population in which the population is what divided into subgroups called what clusters. So remember, stratified sampling, the groups, each group is called a stratum, but plural is what strata. But here we divide them into subgroups, and these groups are called clusters. Okay, and a simple random sample of those subgroups is taken. All individuals within these clusters may be sampled, or a simple random sample may be taken from the selected clusters. So let's also check Google for more explanation. So let's say we are looking at cluster sampling. So cluster random sampling. Alright, so cluster random sampling, and then let me take this. Let's use this picture. Let's use this picture to do the illustration. So now you see the difference. Just look at the difference for cluster sampling. Now in cluster and then stratified, we divide them into groups. So like this, we put them into groups, isn't it? But for cluster, our samples are now the groups. So we divide them into groups, and now we pick samples as the groups. Okay, so we pick group 1 and group 2 as our sample. Okay, so in a way, when I do that, mostly we call it one stage cluster sampling. So somebody will also picking those group 1 and group 2 as a sample. He will then go inside each group and pick sub samples. That is two-stage cluster sampling. Okay, so he divides them into 4 groups, which are called clusters. Pick 2 clusters as a sample. This cluster, group 1, group 4 as a sample. That is one stage cluster sampling. Somebody will say, no, yeah, even though I picked 2 groups, but they still look heavy, so I'll go into this and pick a sample, simple random sample. Go into this, pick a simple random sample as my sample. It's a 2-stage cluster sampling. So that's the whole difference. For stratified sampling, when you divide them into groups, each group you pick a sample from them. But here, the groups are your sampling units. Okay, so you divide them into 4 groups and pick the groups as your sample. And every element in group 4 is taking part in a survey. Every element in group 1 is taking part in a survey. The 2 groups, group 2 and group 3, are no longer part because you didn't pick them as your sample. Right? If you do that, that is one stage cluster sampling. But when you go into it and pick samples from each of the selected samples or groups, is 2-stage cluster sampling. So take note of that too. Alright, so this gives this notice is there on the page, is there on my class page, so those of you on the class can log in and then get the PDF and then go through. Okay, so our next thing to look at is variables. Okay, in statistics we mostly look at variables, because in real life, when you look at something that is constant, you don't really get a lot of fact information from them. Something that varies is good to study that. Something that changes over time is good to study it, because it's not static. If something is static, you know, if the output is 2 every day, 2 every day, 2 every day, why would you study it? There's no need studying that, because that particular thing is static. All the time it's going to give you a 2. But when a thing is variable, it changes. It changes. There is some kind of variation over time. Then you would love to study it and see what is actually happening. Okay. So variables are properties or characteristics of some event, object, or persons